So how do we calculate the confidence interval for a population mean? Well, really, this is very similar to what we did for population proportions, right? First, we have a couple of requirements. The sample must be a simple random sample. We have to have used an appropriate sampling method. And the population must either be normally distributed or the sample size has to be greater than 30. If one of those things is true, then this is our formula for calculating the margin of error. And you notice now, right, we're going to use first S, that's the sample standard deviation. And we've got the sample size down here, that's N. And we're using a t-score here. That's the big difference you have to keep in mind when you're doing these questions. Make sure you're distinguishing if we're finding a confidence interval for a population proportion, you're going to use a z-score. And if you're calculating a confidence interval for a population mean, then you're going to use a t-score. Okay, so once you've got the margin of error, you do exactly the same thing you did with it that we did when we were working on proportions. You do the sample parameter, you do the sample statistic, the sample mean plus or minus the margin of error, and that is the boundaries for our confidence interval. We are reasonably confident, whatever the confidence level we chose was, that the actual population parameter is going to be in that range. So I have an example here for us to look at. A big concern with modern fisheries is the level of heavy metals that show up in large fishes. Large fishes feed on medium fishes that feed on small fishes. So the level of those metals that are relatively small and the smaller fish get concentrated in the larger ones. Right? So we have a sample here, and kind of as we discussed, it's small. Right? And this, again, was the motivation to develop this t-distribution in the first place. It was, to allow us to answer these kinds of questions even when we have small sample sizes. Right? So what do we need to know? Well, we know our formula. Right? Our formula says the margin of error is equal to the t-score times the sample standard deviation divided by the square root of the sample size. And let's see, I know a bunch of this already. I know that the sample standard deviation is 0.165, and the sample size is 7. So I'll have the square root of 7 down here. Now, we need to get the t-score, right? So you're going to go to the t-distribution table, and you're going to look, again, confidence levels, always two-tailed. So you're going to go over to 90%, to the 90% column in the two-tailed section. And then how far down you're going to go? Well, the degrees of freedom here, remember, that's the sample size minus 1. So the degrees of freedom is going to be 6. So you'll go down to row 6, and the score that you should see there, you're going to get T alpha over 2 equals 1.943. So that's what I'll drop in here. Now you get your calculator, you work that out. This comes out to 0.1212. And that's my margin of error. Right, so what is my confidence interval? Well, remember, my confidence interval is x bar minus the margin of error less than mu, the sample mean, less than x bar plus the margin of error. Right, so what is x bar? That's the sample mean, that's 0.393. So my margin of error would be 0.393 plus or minus 0.1212. I am, and how would I state this, right? I would say I am 90% confident that the average heavy metal level is somewhere in that range. So here I've got another example for us to take a look at. And why don't you can pause this one if you like. This would be a good one for you to get some practice with. Then you can start this back up and we'll go over it together. Okay, so what we have here is a car manufacturer, right? And he's producing a new part. Maybe it's a new production process, and he wants to know what the average weight of these parts is going to be, right? So let's see, what do we have going on here? We know that the degrees of freedom is the sample size minus 1. 40 minus 1 is 39. We know that the sample mean is 2.1. The sample standard deviation is 4.8. The sample size is 40. And what is my t-score? Well, we're going to go to the 90% column, right? Still doing a two-tailed test. So you're going to find 90% in the two-tailed row. That'll be the column you're going to use. And you'll go down to row 39. That's the degrees of freedom. And if you do that, you should get 1.685 for the t-score. And now it's the simplest using the formula. The margin of error is T alpha over 2 times S over the square root of N. T alpha over 2 is 1.685. S is 4.8. N is 40. And my calculator tells me this is 1.279. So my confidence interval, it's based off of the sample mean, so it's going to be 2.1 plus or minus 1.279. And if you want to work that out, right, 2.1 minus 1.279 is 0.821, and 2.1 plus 1.279 is 3.379. So I am 90% confident that the average weight of these parts is going to be between those two numbers. Okay, so I have a special case here. They used to kind of emphasize this in textbooks, and it is really kind of one of these things that's being slowly phased out. If you know the population standard deviation, you notice that's what I've got here. This formula looks a lot like the previous one, only instead of S, I have sigma here. So now, if somehow, this is highly unusual, but if somehow you do know the population standard deviation, then you can calculate the margin of error with a z-score. You can go back to using a normal distribution instead of using this student's t-distribution. Okay, so what's next? We've got one more thing to talk about here with population means, and it's the same question we ended with when we're talking about population confidence intervals. We need to figure out how to determine the minimum required sample size to get a certain level of confidence in our results.